In this lesson, we're going to continue with our factoring, and so I've gone back to the factoring flowchart again. Last lesson, you looked at greatest common factor. And if you scan over this entire chart, you'll see that it starts at GCF. You don't think about anything else. If the problem says factor, or if you need to factor, you look at a GCF. You look for a GCF. After that, whether there is one or there isn't one, you look to see if it has 4 terms in the polynomial, if it's a trinomial, which means 3 terms, or if it is a binomial, whoops, that moved, which means that it has 2 terms. And you have different techniques depending on how many terms there are. The lesson we're going to look at in 6.1.2 is 4 terms. The method we're going to use is grouping. And just very briefly, it says try to group the first pair and the second pair and look for a common factor. Then factor out the common binomial factor. And that may not mean anything to you yet, but it will when we start working. All right, so here we are, and we're going to factor by grouping and give myself a little bit more room to work. All right, I have x to the third plus 5x squared plus 8x plus 40. And please remember that if you want these problems printed out, there is a button in my math lab that has the problem sets, and you can print them out, and it's a little easier to take notes when the problems are already written if you want to have the cost of printing something. All right, we look at this. Now, if we're supposed to factor, no matter what lesson it's in, I'm supposed to look at all the terms and look for a GCF. Well, they don't all have a common factor because this one has an implied 1. Do they all have x's? No, this does not have an x. There is no GCF, but I looked for it. I should always look for it. Because there are 4 terms, I'm going to use my technique called grouping. And I'm going to underline the first pair and the second pair. Look at the first pair. Is there a common factor just in this first pair? Yes, I see x in both of them, and I can take only up to x squared because I'm treating this as an independent little group. So if I factor out an x squared, if I want to, I can put the x squared under here to do my division. Here, use the quotient rule, I get x. The x squareds divide out, and I have plus 5. I factored just this much of the problem using my GCF of this little piece. Whatever the sign is, that's the sign that you bring down. Now look at these. Treat this as an independent problem. Is there something in common in just these 2? The answer is yes, 8. Divide 8 into both of those. That will go in there x times, and 8 will go into 40 5 times. Now your problems are rigged. If you're doing it correctly, you will see a binomial there, meaning 2 terms, and the exact same binomial there. You are going to grab it as a common binomial and write it in front. And if you took it and yanked it out of there, what would be the leftover factor? Well, x squared would be left over here. What would be left over here if you yanked the x plus 5 out? Plus 8 would be left over here, and you're done. You have factored that by grouping. So the only part that's kind of, you just have to get a handle on is once you've worked with this group and worked with this group, you see a common, not just a common factor, but a common binomial factor, and you grab it and you yank it out and you put it in front. The other factor, which sometimes I call the leftover factor, is simply this term and this term. Okay, let's play with another one. All right, I have 3x plus 9 plus xy plus 3y. I look for a common factor across all of them. And at first I think maybe 3, but then I look at this term and it doesn't have a 3. Do they all have x's? No, some of them do. Do they all have y's? No, some of them do. There is not a GCF for all of them, but there are 4 terms. 4 terms means try grouping. And it will work just fine if you grab first group, second group. Look only at the first group. Within the first group, do you see a common factor? Yes. Hopefully you see a 3. Now I'm going to stop writing the 3 under those, but you certainly can. And if you have trouble following it, you can ask your teacher in class about it a little bit more. That's going to give you the 3's divide out, leaves you with x. 3 goes into 9 3 times. Remember, bring down whatever the sign is between them. What's the common factor here? Y. Y goes into this term, canceling out itself, leaving you with, not canceling, sorry, dividing out itself, leaving you with just an x. And then if this one is divided by y, it will leave you with a 3. So remember, you can do this if it helps you. Okay, now if you're doing it right, the binomial in parentheses will be the same. If it's the same, you can factor it out. So I put it in front, and if I grabbed it out of each of these, it would leave me with, and now it's a factor, this is now multiplication, it will leave me with 3 plus y. If you were to do FOIL here, I'm just going to show you how you could check it. Do it by FOIL, product of the first. X times 3, I would call 3x. Outer product, x times y is xy. Inner product, 3 times 3 is 9. Last, 3 times y is 3y. This is first, outer, inner, last. These are not in the same order, but the commutative property of addition says they're equal. So I do have the correct factors, and I used grouping. Let's do another one. I have 9x to the third minus 15x squared plus 6x minus 10. I look at it and I see that there is not anything in common in all the terms. So since there are 4 terms, I will try grouping, and hopefully there will be a common factor in each little group. All right, in this first little 2-termed group, I see that what will go into 9 and 15? The answer is 3. And they both have x's. I can take only the low power, so x to the second. And I said I wasn't going to do this, but I changed my mind. I'm doing it. All right, what will that leave us? 3 goes into 9 3 times. Subtract the exponents, and you get just x. 3 goes into negative 15, negative 5 times. The x squareds completely divide out. I can close parentheses. Remember to always bring down the sign between them. What will go into 6 and 10? The answer is 2. 2 goes into 6x, 3x times. 2 goes into negative 10, negative 5 times. You can just look at this and see if you've done it correctly. The common binomial factor, the factor with 2 terms in parentheses, is 3x minus 5. And when you factor it out, you are left with 3x squared and a plus 2. Please notice that from this step to this step, you have changed from an addition problem to factors. You're factoring that out and putting it in front, and it's leaving you with 3x squared plus 2. So that's your answer. Okay, let's keep going. We have, I think, 2 more to do. Oops. Guess I went a little bit too far. There's our problem. All right. I have 4x squared minus 16xy minus 5x plus 20y. Is there a term that goes into all of these? 2 goes into most of them, but not this one. X goes into most of them, but not this one. Y goes into a few of them. The answer is no. There is not a common factor to all of them. But there are 4 terms. So first group, second group. First group, common factor, 4 goes into both of them. They both have x, but I can take no more than plain old x. So divide by 4x. Sometimes by x's. There we go. All right, the 4's divide out. X to the second over x leaves me with x. 4 goes into negative 16, negative 4 times. The x's divide out, and I have a y. Now, this is the first time this has happened to us, but that sign is negative. That means that when I find my little factor that I can factor out of this group, it's going to be a negative factor. 5 goes into both of these, so what I'm going to divide out is negative 5. If you don't see it as negative 5, the signs will mess up. Negative divided by negative is positive, and the 5's divide out, and we have positive x. Positive 20 divided by negative 5 is negative 4, and there is a y. And let's see if I'm on target. This binomial is x minus 4y, and this binomial is x minus 4y. It's a common factor. I get to write it out in front. The other factor is 4x minus 5. Minus 5. Really watch out for those signs. And it all started right here. This is the sign that always comes down for the common factor of the second group. All right, let's see what happens in this last one. I have 2q squared plus 9pq minus 2q minus 9p. There is not a common number. There's a q in 3 of them, but not all of them. There's a p in 2, but not all of them. So no common factor to all. So I will group them because there are 4. In the first group, what's in common? Not a number. Looks like a q. So I will factor out a q. I keep the 2. Q to the second over q to the first gives me a q. Plus sign. These q's divide out, and I have 9p. So q went into that 2q plus 9p times. I'm being observant, and I'm noticing that there's a negative there. Well, there doesn't appear to be a common factor. What I'm going to do is say then I will have a common factor of negative 1. Negative 2q divided by negative 1 makes it positive 2q. Negative 9p divided by negative 1 makes it positive 9p. If you're doing one of these problems and the second group does not have anything in common, then what you will write will be a 1. If this is plus, it'll be a plus 1. If this is minus, it will be a minus 1. All right, we see a common binomial. That leaves me with 2, that factors out 2q plus 9p. That's my common binomial. The other factor is q minus, you have to write the 1. It's no longer an implied one. It was implied when it was being multiplied, but now it's standing alone. It's not implied. All right, so that lesson was on grouping. If I went back one more time and took a look at this, greatest common factor is always first. If there are 4 terms, you go to grouping. The next few lessons will cover all of these. Okay? Do your homework.